I will explore the role of satellite technology that can support overcoming these challenges. We hear about some of these success stories that how satellite observation contribute to monitoring forests in this region. Here's today's agenda. There are 3 segments and invites 6 speakers. Our first agenda segment focuses on gaining valuable insights into the integration of satellite data. We have these 2 English speakers lined up to provide us with comprehensive overview. Okay, I will begin with an overview of the current status of systematic observation from space. Please welcome Frank Martin Seifert from European Space Agency and moderator.
Yeah, as well from my side, good morning everybody. I'm glad to share it with Mariko, this side event. And you're uploading? Well, these side events, we are working closely together since several years with JAXA, with the systematic observation community for the Paris Agreement and there specifically the Global Stocktake. Paris Agreement, we are aiming to limit the global warming to 1.5 degrees. We know we are not on track related to it. We have to raise ambition, and that's why the Global Stocktake is coming in. It's a mechanism which was set by the Paris Agreement. Within the Paris Agreement, the parties have to report on their national in the first Global Stocktake. It was set up in 3 parts: an information collection and preparation parts. That's where we, as a systematic observation community, were contributing with a synergy report. You see the link of the synergy report here on the slide. It went to technical assessments during last year and this year, and we are here today at COP28 to consider the outputs. The output should, in principle, increase ambition and stimulate climate action. We saw yesterday evening a first draft related to the global example of a space-based, a quite complete space-based system, which we put together with the European Commission. That is a Copernicus system with a fleet of satellites. These 2 elements, the area plus the biomass map, gives important input towards the national greenhouse gas emissions. And with these 2 examples, I'm heading over to my colleague Martin Herold to talk more about what is
in the Global South. And there are more than 50, 60 countries involved, and it's a lot to really bring new Earth observation and monitoring tools into countries to improve the capacities for national greenhouse gas estimation and reporting. And focus here is, of course, on the forest. So these components work hand in hand. And if you look what has been achieved, and I'm showing a couple of maps, so you know the resources are there, but I want you to focus on the green map. So the green map on the left-hand side from yours shows where countries have improved their capacities in the last 15 years to use Earth observation data to report on the forest area and the forest area changes. And you see a lot of green. You see a lot of tropical countries have been able to use Earth observation data for their own reporting and improve their own reporting. And that's basically throughout. Some countries were already in good shape, already in 2005, Brazil, for example. So there was not much improvement compared to kind of an international standard, but a lot of countries have been able to catch up and really make use of that. The green map on the right-hand side, it shows where countries have improved capacities for their national forest inventories, which are ground-based, so ground-based forest inventories. And there we also see a lot of improvements over the last 15 years, which is good. So the forests are looked at from above and looked at from on the ground monitoring. And so in particular, when it comes to forest and forest area change, the use of observation data, the use of satellite is already well established, and countries have really been able to really use them, in particular the free and open data coming from Landsat and the Sentinels for their own purposes. Of course, not all gaps are filled yet. A lot of focus is still on improving monitoring of forest degradation, monitoring of forest regrowth, estimating the carbon sinks and things like that. There are still some capacity gaps to be filled, but that's not unique to the tropical countries. Also many European countries and northern countries are struggling with that. When it comes to the national forest inventories, ground-based, it's very good that we see these improvements. What is fair to say is all of these inventories are mostly one-time efforts. So they've done once, and there's now a bit of a struggle to keep them up to date, because the idea is that you do forest inventories on a repetitive basis to measure changes, and changes in forest, particularly, for example, to estimate the forest carbon sink and stuff like that. And that's where the struggle is. So also there, a new Earth observation data sources can help, in particular in estimating biomass and biomass changes, and that is a new area where we are actively working at the moment, from research to operational demonstrations in countries and eventual uptake in the countries themselves. And we make use for some of these data products that was already alluded to. So global biomass estimation using space-based data is really evolving, or has evolved over the last years. There are dedicated missions, satellite missions, just for that purpose, to better estimate biomass, particularly in tropical countries. And we're now working on ways on how data from the space and data coming from the forest inventories, which are ground-based, can be integrated to improve the precision and also update these estimates on a more consistent basis. So there are work with several countries. For example, there's work in Peru, in Guyana, Tanzania, Mozambique, several other countries, which is now also coordinated by the Global Forest Observation Initiative to see how that can be streamlined also into country efforts. There's also work, and that's a bit more related to the Global Stocktake, on trying to understand and align as needed information coming from national greenhouse gas inventories and those coming from Earth observation-based global data sources. And if you look, there's several research studies that have been published on that. And if you look at it, when you initially look at the data, just look at the global estimates, you will find that they are quite different. And sometimes that's a bit striking to some. But if you really dive in and you really take the country data, use the country forest definition, use what the country defines as managed lands, and use the same categories the country is reporting, you get to quite reasonable alignments already based on rather independent data sources that can be done. And that's a very useful exercise in light of the global stocktake, so to better compare national to the global and vice versa, and also maybe point out where further improvements can be done. So to sum up, there have been important achievements, and the use of Earth observation and the uptake in developing countries have made big steps forward. That was possible through coordinated efforts among the technical community with international organizations and research and country experts. What's really next on the agenda is really to work more with countries on integration of these base-based data for biomass in the national forest inventories. There's still a lot that can be gained in actually using Earth observation data more to estimate forest regrowth and the carbon sink. We do see an increasing not only interest, but also increasing use of the greenhouse gas inventory information or the data that are behind the national greenhouse gas inventory towards climate action. What's very important here is that data are timely, so are reasonably up to date, that they are spatially detailed, so they really can inform policies and also climate action on the ground. And we do see these alignments towards the global stocktake to better understand potential differences between the global and the national, and I think that's something that's kind of starting up now. It might not have had a big impact on the current global stocktake, but for the next global stocktake, I think this is really something, well, we should be much closer then to align things and understand differences for joint better understanding. Thank you.
Thank you.
And that is a perfect step over to Osama Ochai from JAXA, who will talk about the future of the observations.
Okay, great. Thank you so much. So good morning, everyone. My name is Osama Ochai from JAXA. Today satellites, which is comprising of a public space agency organizing, coordinating about the process. And then we are going to have really nice, very important moment about can make sure how much emissions to be already emitted about, and also how much absorption things already been happened. And then this is a time frame that we can really important for us as well, for the Earth observation data providers, to provide our science-based information to utilize users, global basis, also the country basis. So again, this is really important time frame from now on to the next 20 years, so on and so forth. So again, as Frank Martin and also Martin Harold mentioned about, we have some sort of a global data set, also country use case has already been happened something, but we need to assure entirely about how much our space-based assets to be flown, community of the missions, as well as the data exchange and data to be available to the users. So in doing so, we need some sort of roadmap to discuss how we can ensure the long-term observation, to share the data, we ourselves to make our roadmap. We call it a sales AFOLU roadmap, agriculture, forest, and other renewals roadmap. This includes a context about the IPCC requirements and how Earth observation can support for the activity data, and how Earth observation data can support for the emission factors. And as Martin mentioned about the capacity building and stakeholder engagement, are quite important for us. How is a better way to do so? And then finally, integrated monitoring and verification system. And then we have such a set of recommendation, as you can see these slides. And then again, that's ensuring that every country has the land satellite data required to report the unit that we will maybe improve our data sets accordingly. And so this is our priority work to do so. And then GHG observation from the space is addressing accordingly expected about the result. Maybe we can hope to report back to the next COP meeting. Thank you very much.
Change the configuration of the panel. So now I'd like to invite three speakers on the stage. You still here?
Of this FREL in July, and we are now working on the inclusion of emissions in the case of Bolivia. The red bars are showing deforestation, and the orange or lighter pink are emissions from degradation. So our first FREL only included deforestation, but the recommendation is to include health in Bolivia. We, of course, creating a network of permanent plots to validate and all these efforts. And of course, we have to this are coherent with the efforts on the climate change efforts, and an issue that also should be raised. We should mainstream gender on these MRV efforts that we are carrying out. Thank you very much.
Thank you, Natalia. Now I'd like to invite Dama-sama.
In here is the 2020 land use, land updating, the landscape. The approach is mainly overlaying and integration of the existing or the current NAMRIA land use land cover map 2020, and overlay that with the Pulsar 2 forest non-forest map. So just at the box at the bottom left is just to reiterate again the definition of a FAO with regard to forest. So it is land spanning more than half a hectare with trees higher than 5 meters and a canopy cover of more than 10%, or trees able to reach these thresholds in situ. Okay, it does not include land that is predominantly under agricultural or urban land use. Okay, for the other land rest. Okay, so to overlay these and come up with the column that we have on the third for the FAO category. So, for example, for the open forest, closed forest, mangrove forest, all of these are forests under the ALOS pulsar. So that will go into the forest category in the right-hand column. For the brush and shrubs, again, the pulsar will have forest and non-forest. So if it is forest, then it will be categorized as forest. And if it is non-forest, then it will be categorized as underwooded land. For the perennial crop, annual crop, and built-up land cover classes, so again, using pulsar, it will be identified as either forest or non-forest. If it is a forest, then it will go into the other land corresponding to FAO's definition of other land with tree cover that were previously unreported. Now, computing for the amount of carbon that these additional lands with trees has sequestered, we have an estimated additional of 145,480 gigagrams of carbon dioxide per year. Okay, of carbon sinks. Okay, and we have also published this study in that paper, okay, under the International Journal of Applied Earth Observation just recently. Okay, so we presented this study to Philippine government agencies involved with forest monitoring. We started a meeting with the Forest Management Bureau way back in September. And also, just a couple of weeks ago, we presented it with the national, computed by NAMRIA. So maybe there is now a need to rethink the mapping approach by NAMRIA, by the Philippine National Agency. Okay. And another feedback is that it is useful to have an area estimates of other land, no, with tree cover, as there are no official statistics that exist on this one, on this class. Okay. With regard to the potential use of pulsar 1 or 2 images, okay, so this is the feedback from my country. Okay, NAMRIA, okay, has previously used JAXA imagery to come up with the national land cover way back in 2010. This one is basically the visual and near-infrared images from JAXA ALOS 1. Okay, and NAMRIA is very interested in using pulsar 2 data for monitoring forest and other land cover in the Philippines. However, they haven't had used this type of imagery, the SAR, the synthetic aperture radar imagery, before. So they have stressed that there is a need for capacity building and detailed guidance on how to visually interpret and process this type of SAR images. Okay. NAMRIA officials have also stressed that it is critical for JAXA to keep providing this data continuously, freely available in the future. Okay, and so this is just visualizing pulsar 2 and the visible image. Okay, so lessons learned from this meeting, okay? So about the usefulness of this case study, it was good a way to familiarize our government officials from FMB and NAMRIA regarding pulsar 2 data through the forest, non-forest map, okay, and get their initial interest, okay. Make changes in national reporting of forest cover and other land recover. This path is not necessarily direct or easy, and NDCs, of course, yes. We first approached the FMB, but then they were told that they fully rely on the data from NAMRIA. So, to help the FMB in reporting forest area for statistics, we first need to cooperate with NAMRIA. Okay, and the meeting with NAMRIA a couple of weeks ago was very fruitful and very promising. Okay, but then again, this will require follow-up, no, with capacity building efforts to enable NAMRIA, okay, officials to really understand the pulsar data and how to use it for their own, for our national land use land cover mapping. We haven't accomplished it yet, but we are hoping that the lessons learned from this will help us achieve this goal. So that's all from my presentation. Thank you very much.
I'm Sandro Federici from the Technical Support Unit of the Task Force on National Greenhouse Gas Inventories of FAO, where I should... Sorry, of IPCC. Okay. Okay, we released the new version of the IPCC inventory software. We have a side event at 4:30 in the afternoon in building 88. There is the IPCC pavilion, is totally blue. There you may have a lot of information. You may also see a demonstration on how the software works. This version implements all the methodological tiers, and we will talk here about land representation, that the IPCC guidelines provide. It calculates the entire greenhouse gas inventory and also allow to transfer, you see, because there is interoperability functionality, all the information through a specific JSON file to the UNFCCC ETF reporting tool. I will This is an example of the software, but I invite you to come to our presentation, which is more dedicated. Meeting all the Paris Agreement requirements, which means mostly on the interoperability. The current version is still not have interoperability for LULUCF, which is the most important in this event. But we'll have possibly in February, March, we will release that version. We are working on time series export-import because what is important to know is that National Greenhouse Gas Inventory is not a single year inventory, it's a time series. Each year you estimate a time series of annual inventories. We are working on the uncertainty analysis, which is also very relevant for your activity with remote sensing, because often the uncertainty analysis of remotely sensed data is a relevant piece of work. We are producing guidebooks to help the user, and there is already a guidebook published that is just on land representation. Anyhow, I guess the presentation will be available, so if you come to the event, it will be almost this one. So why the land representation here? It's true that the remotely sensed data can be used as data set for for a number of categories, a number of typology of data. However, the key element that require remotely sensed data is the land representation. The land representation is, in a greenhouse gas inventory, the most time-consuming, data-intensive piece of work. No any other sector has this complexity. It's also not easy to do. It's prone to error. Is the main things that a reviewer check when they review your inventory, because it's at the basis of all the estimate in the land sector. A land representation deals with two important elements. The first is the classification of land. But the land is not just that. We classify the land because we need to stratify the land. We have methodology, at least as most as possible. Not only in terms of carbon stocks, but also in carbon dynamics. Classification, you need to track, to identify units of land. So those land that are homogeneous, not only for the current land use. We have been working with the FAO, but the work is not going very fast. And we are trying to speed up this work, so if anybody wants to join to this effort, is most welcome. We are looking for support. To an add-on, so the software per se doesn't do the land representation. So you need to input the land representation in the software. It takes time, it's complicated. So we are working on a tool, so another piece of software that does the land representation per se. So you need a customization of the, I say the mask, probably you will say the playground, I don't know what you want to say. That is for the data collection. This tool we are working now is just for sampling. We were working on two tools to wall mapping. But now I want to present only one because the other one is by far more complicated than this to realize. And we think that we should prioritize the release of one of the add-on at least before going for the second one. because there is a lot of requests of this tool. So you of course you collect, then you know through a big limit when you go with wall-to-wall, which is of course very nice. Then you need to work with the data, not just pixel by pixel the estimate, because the error that you have in the pixel in terms of land classification, even if you do a study of the bias, you don't remove it because the map remains, and then all these propagate in the inventory. But of course, if you then extract activity data also from a map, you correct for the bias, then you have an unbiased estimate of greenhouse gases. So assessing the bias, correcting for the bias, then filling the time series, because again, a national greenhouse gas inventory is a time series, so you need not just one land use matrix, land use and land use change matrices, but you need a time series of those. And then for each year to produce the land representation, which tell you your national territory, how is disaggregated, how many units of land, which are the characteristics of units of land, which is the area of the units of land. And then at the end, this new software should export a file with the land representation that can be read by our software at once. This is what we were working with FAO about, is CollectEarth, which is an augmented visual interpretation. So this is based, the plus of this tool is that connect to free data set, so you don't need any cost for the data. It's a visual interpretation, so can be quite accurate in the data collected. Is very, I mean, it's not so difficult to be used. It's much more easier doing a land interpretation visually than applying algorithm to images. This is a slide from them, and then So, as I said, the work started, but is far to be completed, and we are looking for additional support. If any of you is interested in joining us, please write us. Finally, the software is freely accessible, not the add-on because it's not yet ready, but the software to do the web page. Here you have you have a picture of the web page. It comes in two versions, so you need to check which of the two versions need to be installed on your computer. If you install the wrong one, the software doesn't work. Unfortunately, the software works only on Windows OS, doesn't work on Mac. Again, it's a matter of resources. We don't have resources to produce another version. Hopefully, in the future, will be possible. Us, the technical support unit, provides support to the user of the software. So we are also drafting this guidebook to better help the user, but anyhow, in the meanwhile, we are happy to receive your question. We are also very happy if any of you want to test the software with the data, because we are looking for that. We are looking with many other things. Testing is really a burden that for us is complicated. We have time limits. Okay, and then every year we do a meeting to collect the feedback from the user. Will be also next year, but possibly in the second half, once we have released the final version with the interoperability of the software. Thank you.
Thank you, Sandro, for your excellent presentation. Now I would like to invite all the speakers on the stage to have a discussion with the participants. The speakers, please come. Could you move this way? Could you move this way? I'll be on this. Now let's open the floor for discussion. We invite participants to share any experience, insights, or questions. And please raise your hand, and the microphone will come down to you. And please identify who your question addressed to. Sorry, it's too bright. The gentleman here on second row.
Hello, everybody. I'm Faran Zigou from Gabonese Spatial Agency. No one big users of Copernicus projects, especially for S1 and S2, Sentinel-1 and 2 product for monitoring of forest in general and other related sectors. I can testify that the spatial and temporal resolution of this data are very interesting for near real-time monitoring of forest and other sectors. My question is, do any method or data currently exist on the estimation of flaring data from oil platform? I know that the German colleagues from the DLR are working on the subject, but I would like to know if operational solution already exist at the European level. My second question is toward JAXA. Does JAXA have a support program for countries wishing to use their spatial data? In the specific case of Gabon, we are in the process of developing a system for monitoring mangroves and good penetration of the signal in this ecosystem, but the financial side, you know, in these regards.
Thank you for your question. Frank Marnie, would you like to take the first one?
Shall we take more questions or? Oh, well, since the Glasgow COP26, NEO activity, who is looking at methane emissions coming specifically from oil and gas fields. To my understanding, they are not operational, but they are working towards operational services.
Yes.
Okay. I just want to reply for your second question in terms of the wetland research activity in the Gabon. Actually, yeah, we have several options maybe we can discuss, but the first you can maybe submit to our research announcement to get the data. But in case if you have more deeper thoughts about more cooperation, we can maybe discuss about maybe organizational level. But yes, and also we have some sort of a global mangrove watch data set.
We work a lot at the same level, not only with mangrove, but forest inventory, and the questions will be elaborate, but is not in terms of monetary resources, but is in terms of capacity building. Myself, as a space system engineer, I work a lot with the mangrove watch or other satellites like MORIS and even some other missions for hyperspectral sensing of greenhouse GE and land management. But the problem, again, is what we can afford and I could bring to the table is at a level of capacity building knowledge to really engage either space agencies at different levels, but also at academia level, because some of the resources that we have, human resources, human willingness, and a lot of projects we are taking place. I'm managing 3 different carbon certifications there on natural-based solutions with mangroves, but the idea is how can we really
have 250 bands, so you get a lot of additional spectrum.
Right. So, hello. I'm from Mongolia, Mongolian Aerospace Research and Science Association. I'm also participating at the COP, representing Mongolia as a party delegate in negotiations. I have two questions to JAXA and ASA. MARSA, that's Aerospace Association. How do we know what?
How much, which years you might want and how long you might want to take. So that's for the time being.
Okay. The program is for the next decades. So related to the future, we are planning to launch Sentinel-1C, Sentinel-2C. The data stream will be there, will be even improved, and might even get more temporal and better geometric resolution. If we are going back in time, then we are very grateful towards the US with the USGS operating the Landsat series, which goes 50 years back in time, into the 70s. I don't think that you want to go back into the 70s related to land use issues, but in principle you could. The resolution is not as good as today's satellites, but it gives you already a good indication what was happening in Mongolia, let's say, in the 80s. Related to radar data, we had during the 2000s until 2011, we had NVSAT from ESA. There's a long history of L-band SARs from out JAXA going back in mid-90s. C-band not so systematic as later on the Sentinels, but still with coverage which gives you indication on what was happening 30 years ago in your country. More difficult to get all the things together, but there's a possibility to do so. And there are initiatives to bring this type of historical data to be more accessible for the generic public. As I said in my presentation, the data from ESA are all free and open.
Thank you. Now I'd like to take the in the middle.
Thank you. Christoph Sanier from GAF in Germany. There's a question to Sandro. When you had a slide on Collect Earth and you said work was still in progress. I mean, do you mean in terms of software development or in terms of actually collecting activity data?
No, software development, because we want to transform Collect Earth in an app that does not only allow to collect information on the land use and land cover, but to elaborate this information in a land representation. So calculating the bias, correcting the bias, gap filling time series, and exporting the entire time series.
Thank you.
Thank you. I'd like to take the next question. Okay, there.
Good afternoon. I'm from Papua New Guinea. Chalapan Kalwan is my name. We're probably the biggest ocean in the world, and I have some in the Pacific. And then we're the third largest forestry country in the world too. Listening to your presentation with the satellite and so on, we have some partnership with dealing with, say, Indian Space Agency. We're using certain technology here, developing the IPCC, the 2006 index, the methodology, how to calculate the emission factor as well. So we're all from different parts of the world, except my question to you is, and it's quite important to countries from the Pacific. Do you have any technology in terms of resolution to go down, say, 1 to 2 meters or 1 millimeter resolution or 1 centimeter resolution? Because this is an emission factor issue that from various parts of the world, we're looking at forestry, we're looking at this, satellite cannot go down to the bottom. So we send our landowners to go and do the measurement to see what sort of tree it is, because you don't go down there. So under the emission, under the inventory that IPCC 2006 when we developed it. A number of us were part of the group that we developed it. That's my question to you. Can you do the measurements in the ocean on blue carbon in relation to seagrass, corals, and so on? And how far do you go down the ocean? So any of you can answer that, but it'll be interesting to see how we handle it, because that's some of the challenges for people like us. We've been dealing with research at the university level right across the world, including our friends from NOAA. Thank you.
Yeah, thanks for the question. I'll take a step, and then perhaps others can follow. So in terms of the spatial data from the satellite data you're asking, so there is the data, most of the data that were shown here, the Sentinel. There is a commercial, there are commercial providers. We have Maxar that goes down to sub-meter and stuff like that. These satellites are also out there. You can acquire that data. You can task the satellite to acquire data at a given cost. So there is a cost associated, which is something that you have to factor in. We see this happening in particular if you're not necessarily going for maybe wall-to-wall coverage of the country, but you want to zoom in, for example, in your plots where you measure on the ground, or these kind of things where you can maybe use some of this data to support that kind of work. That is also typically the kind of data you can find on Google Earth, right? If you look at visually, some of these data that are a bit higher resolution, that those are coming from, in parts coming from these satellites. So yes, some of the data are there, not centimeter resolution, but down to half a meter. It's possible, it's commercially available. So that's the opportunity there. When it comes to oceans, there is actually a whole world of ocean observations out there. For large area, they tentatively work on even coarser resolutions, because often them ocean features, you look at larger areas, so they are at a series of a couple of hundreds of meters. But if you want to look at seagrass, corals, kelp, and these kind of things, there are some of these optical systems that we have presented are also useful for these purposes. Is a key issue. So how much does it penetrate? And that depends a lot on how clear the water is and how turbid the water is. So you have to really depend on the clear and non-turbid conditions. You can look in the visible wavelengths, the visible blue, visible green. It can go up to tens of meters, but that's under ideal conditions. So, but since you have a time series, you basically can wait and see whether you have the right resolution. But then I'm not an ocean expert, so maybe other.
Well, I'm as well not an ocean expert, and the main topic of today was related to land observation. But yes, coastal zone, and for instance, Sentinel-2 is acquiring all data over land plus 100 kilometers into the ocean. So the coastal zones are covered, and colleagues of mine are looking specifically at blue carbon. Not only the mangroves growing at the coastline, but as well towards seagrass, sargassum, and they were using these data sets to get an estimate as well of the biomass under certain conditions, as Martin was describing, turbidity and clarity of the water. You can use this data. With the amount of data, there is a good probability that you can assess as well the vegetation in the near coastal area. But I don't want to go further into details because that's not my field of expertise.
Yeah, I just want to supplement about the JAXA also has some sort of a coastline monitoring and ocean monitoring satellite we call the GCOM-C, which on board for the SGLI multiple spectral sensors. And then resolution is a 250 meter. Unfortunately, it's slightly coarse resolution, but it's so capture about the seagrass as well as ocean eutrophications and also chlorophyll A, such kind of a parameters can be detected, but the data is freely open available. Thank you.
Thank you. Now take the next question. The gentleman on the third row.
Yeah, hello. My name is Sebastian Brandes. We run an NGO doing, among other things, a lot of afforestation in Ethiopia. Now, you're talking about the public sector a lot, but we are interested in leveraging money in the private sector, which has been discussed in the conference a lot. And there's one method, which is a voluntary carbon market, which has recently been under scrutiny because of the lack of additionality, and a lot of certifications have not proven to be actually delivering what they promised. So my hope is, being a trained physicist in my past, that scientific data will allow to measure much better the actual carbon sink produced, to bring back trust. And I think we have a lot of donors who would pay once they have a scientific basis of how much data was, how much carbon was actually stored. Now, therefore, my question is there already public scientific publications that give us a variance or a standard deviation of what the current data can provide in terms of carbon stored in the forest per hectare? Maybe it's 20%, 20%, whatever. And do you see a future in the next 2 to 5 years that it can come to a significant level so we can build back trust in the voluntary carbon market? I think that will release a lot of money, knowing what's happening in the market. Thank you.
I can start with this. So we showed there's improving fleet of satellites targeted towards estimating forest carbon stocks, right? And these work mostly with active remote sensing system, active meaning radar, to penetrate in the forest, and LiDAR, which is optical, looking downwards, getting a three-dimensional profile of the forest. And a combination of height and structure is basically the proxy that's being used from space-based data, calibrated by ground data to get an estimate on the carbon stocks. If you look at the current global maps, there's been some validation exercises. They are published, we can provide them. And there's a couple of things to consider. First of all, it's always the question of what uncertainty matters. On the pixel level, right, so you have 100 by 100 meter pixel, for example, you have a biomass estimate on a 100 by 100 meter pixel. On the pixel level, the uncertainties are still very high. And that's because these are reasonably noisy. So if you really want to get the estimate at that point, for that location, you have some, I think an RMSE of 30–40% easily, depending on where you are. If you look a bit more systematically, you have two problems. You have either a bias, you have systematic over or underestimation, or you have a variance. And the problem is really the bias. I mean, if you have a systematic over and under, you have just a variance that averages out, so random errors that average out, or if you go to a reasonable large area, you still have a reasonably good estimates on aggregate levels. And that's what we are finding, that if you aggregate to some extent, maybe at certain spatial units, administrative, project boundaries and stuff like that, your estimates are getting better, because even some of the biases cancel out, but there's a major bias still, or main bias that's getting smaller, that we underestimate high biomass. That's really a problem in this high biomass, because separate between 300 and 400 tons of carbon and so on is relatively tricky. Maybe that's not so much of an issue for Ethiopia, in fact, because the carbon stocks aren't that high. So basically, on the pixel level, still a lot of uncertainties. On aggregate levels, things are reasonably good, and you can, if you have some good ground data, you can prove that, and there's some scientific papers on that. And of course, the technology is improving, and in fact, one of the key limiting factors we have at the moment to do better from space is actually having a good ground-based reference. So we're getting to levels of details that we even from ground-based have challenges to measure, and that integration, the combination of the two, that will give us the really high quality that everybody is looking for. That's for stocks, and then for stock changes, it's a bit more tricky, because a loss, if a forest goes from 300 to 0, right, that's the difference you can see, right? But if you have an annual increment of 1, 2, 3 tons, right, the method's currently only sensitive over cumulative periods of time to actually see this kind of differences.
And often these cumulative measures, they are within the error band of the individual ones, so we still have to work on methodologies to assess this better. Currently related to global observations of biomass, space agencies are working together to harmonize their different maps to look at where are the differences, to bring these error bars further down. What Martin was saying, we are quite confident on coarser, larger scale level, but when it goes towards local level, let's say project level type of size, the accuracy is not good enough. We are as well working with regulators to see how we can make their methods more transparent, improve the accuracy, but that's work ongoing, and in principle you raised the $1 billion or euro question, and which everybody would like to have an answer. We are working towards it, and because this market perspective is one important element to reduce.
And with the Secretariat, put a lot of questions on uncertainty. So we are doing a lot of work calculating uncertainties on the maps, on the carbon stock. So I think we are comfortable with the data that, in the case of Bolivia, we have, given our circumstances, non-Annex 1 country. But I think the issue with the carbon market is also mainly related to the position of national governments to regulate what's going on countries, because it's not only about the certainty on the monitoring, because we are comfortable in the work we are doing, but there's a lot of work yet to be done in the regulation in national countries regarding voluntary carbon market initiatives. There is an issue there, and in terms of methods, we are improving. Of course, every year there is something else to try, some work better to be done, but we are on the track.
Make it pretty brief.
Japan is, as I mentioned, Japan started about our 3 years, satellite communities trying to contribute for the global stocktake as also carbon market. So we will maybe.
Thank you. Because of the interest of time, I'd like to take one last question. Okay.
Carbon inventory, national greenhouse inventory, and we are producing the activity data of the tidal marshes by using the Landsat data, because the inventory must be measured from 1990. So, but if we want to achieve the NDC goals, what they want to do is the restoration, right? So every local communities and private sectors asking us that how they put their efforts to national greenhouse gas inventory for restoration, how we restore exactly, like how many hectares and density of the plants, and then if you have any experience about that, please share yours. Actually a little bit different from the like such definition documents like FAO's documents of forest.
Maybe before discussing more expertise here, restoration may be a different story for us. Actually, we are now focusing on more kind of how much eroding and more change can be detected by satellite so far. And the restoration we are foreseeing about how we can do by satellite data. Maybe.
I think we should discuss after the session that we are getting close to it, and we would like to get more, let's say, more detail what you really want to understand, and see that we can provide you some answers. Well, with this, I would like to make some final remarks. We saw that systematic observation which underpin climate science and services related to mitigation, adaptation from the local over the national towards the global use are available. Often they are, these are free and open data shared. So with everybody, you can integrate it either for commercial services. You can integrate it for reporting services. You can look at it for project-based, taking into account how suitable these data are. There are methods, what we heard, which are to transfer and calibrate global data sets towards national necessities. A large variety of Earth observation sensors from space, either optical, hyperspectral, LiDAR or SAR, are available today, and we heard that there will be even more available tomorrow. So the information flow as well into the future is relatively secured. There are possibilities to look back in time because we are archiving all the data, which is important towards to understand how the development over several decades has happened. A lot of ground knowledge available in the countries is needed to combine and get more out of the data. Only in the combination of this ground knowledge and the more panoptic space observations, we get closer to what we get better information with less uncertainty, and which might then solve the $1 billion question. So this cooperation between the different groups is really essential. But that is what COP is all about, cooperating together for the final goal to limit the temperature rise to a level which is suitable as well for future generation. Let's continue to work there. A final remark, Sandro mentioned another side event. This afternoon I would like to mention one at 3 o'clock in the ESA pavilion, which continues to look at national greenhouse gases, cross-checking national greenhouse gases inventories from space. The ESA pavilion is in building 88 on the ground floor. Looking forward to see many people from you as well there. Thanks a lot for coming.
Thank you for your participation. That's all. Thank you.